The Colorado River Basin has lost 42.34 million acre-feet of fresh water, not to evaporation alone, not simply from a lack of rain, but drained from a system that supplies 40 million people. As of this month, July 2026, the nation's largest reservoir, Lake Mead, is projected to tie its all-time historic low of 1,040 feet. The iconic bathtub rings are wider than ever. But here is the detail the photographs do not show. Of that massive water deficit accrued since 2002, nearly two-thirds of it never came from the river at all. It was pulled from underneath the ground. 65% of the loss is invisible, pumped from aquifers that cannot be refilled on a human timescale. A far greater crisis is unfolding in the dark, beneath the cracked mud and the exposed canyon walls. To understand what is happening to the American West, you have to understand the century-old math that built it, and the new math that is now unbuilding it. The system was designed in 1922. The Colorado River Compact was signed, dividing the river's water between 7 states based on an assumed annual flow of 16.4 million acre-feet. That number was not just an estimate. It was a fantasy. It was calculated during one of the wettest periods in the region's last 1,000 years. Brad Udall, a senior scientist at Colorado State University, is blunt about the history. There were plenty of warning signs, even back then, that there was not enough water in the river. Scientists at the time warned the compact commissioners their figure was dangerously optimistic. According to Udall, they basically ignored the science. The result was a legal framework that promised more water than the river could ever deliver. For a century, the entire system has been running on a lie. Then the bill came due. In the year 2000, a regional megadrought began. Not a dry year, not a dry decade, but a continent-altering shift in weather patterns that scientists now call the driest period in the American Southwest in 1,200 years. The average annual flow of the Colorado River, once measured at 14.6 million acre-feet through the 20th century, has plummeted by roughly 20%. The river now delivers about 12.4 million acre-feet in a good year. The cause is not just a lack of snow and rain. It is heat. Since the 1970s, the upper basin, the mountainous region where the river is born, has warmed by about 3 degrees Fahrenheit. That heat is directly responsible for about 1/3 of the river's decline. It bakes the soil, stresses the plants, and pulls moisture straight from the snowpack before it has a chance to melt and become water. The entire region is experiencing aridification. It is not just a drought. The climate itself is changing. This is the part the headlines do not fully capture. The water level at Lake Mead gets the attention. The stark, white rock of the bathtub ring is a powerful symbol. The reservoir was designed to hold water up to an elevation of 1,229 feet. Today, in July 2026, it is projected to sit at 1,040 feet, a direct challenge to the record low set in July 2022. Its sister reservoir, Lake Powell, is in even worse shape. It started the summer of 2026 at under 25% of its capacity. The Bureau of Reclamation's own models show it could fall to 3,499.19 feet by this December. That is perilously close to the critical threshold of 3,490 feet. That elevation is the minimum power pool. Below it, the turbines inside Glen Canyon Dam can no longer generate hydroelectricity. A common misunderstanding clouds the public perception of this crisis. The minimum power pool is not the end. Deadpool is the end. At Lake Mead, the minimum power pool is at 950 feet, an elevation the Bureau of Reclamation only achieved by installing special wide-head turbines between 2011 and 2016 to function in lower water levels. But Deadpool is the point of gravitational failure. At 895 feet, the water level in Lake Mead would drop below the lowest river outlets in Hoover Dam. Water would physically stop flowing downstream. The river would cease to exist past that point. The system would be broken. What happens at the dams is a visible slow-motion catastrophe driven by water that simply is not arriving. But the real story, the one that defines the next phase of this crisis, is about the water that is disappearing from a hidden reserve. In May of 2025, a groundbreaking study was published in the journal Geophysical Research Letters. A team of researchers from Arizona State University, led by Karem Abdelmohsen and senior author J. Famiglietti, used satellite data to perform a complete inventory of all the fresh water in the Colorado River Basin. Not just the water in the lakes and rivers. All of it. Surface water, soil moisture, and the vast ancient reserves held in underground aquifers. They used data from NASA's Gravity Recovery and Climate Experiment, or GRACE, a pair of satellites that can detect changes in Earth's gravity field caused by the movement of massive amounts of water. The period they analyzed was from April 2002 to October 2024. The numbers they returned were staggering. Over those 2 decades, the basin had lost a total of 52.2 cubic kilometers of freshwater. That is 42.34 million acre-feet. An amount of water so vast it defies easy comparison. But here is the critical detail. The researchers parsed where the water came from. Of that total loss, a staggering 65% was groundwater. The water pumped out of the earth was vanishing too, 4 times faster than the water disappearing from the reservoirs. For every gallon of water that evaporated from Lake Mead, another 2.5 gallons were being pumped from aquifers that took millennia to fill. This is the invisible overdraft, the slow draining of a savings account that no one can see. The burden is not shared equally. The study revealed that in the lower basin states of Arizona, California, and Nevada, the problem is far more acute. There, 71% of the total stored water lost since 2002 came directly from groundwater. The reason is agriculture. As surface water allocations from the Colorado River have been cut back year after year, farmers in the desert have turned to the only other source available. They have drilled deeper wells and pumped ancient water to irrigate 5.5 million acres of farmland. J. Famiglietti, a renowned hydrologist and the science director for ASU's Arizona Water Innovation Initiative, is clear about the implications. Everyone in the U.S. should be worried about it, he stated, because we grow a lot of food in the Colorado River Basin. This is not an abstract environmental problem. It is a direct threat to the food supply of a nation. The water being used to grow that food is finite. When it is gone, it is gone. And there is another hidden mechanism accelerating the crisis, one that begins hundreds of miles away from the farms and cities, high in the Rocky Mountains. In March of 2025, a different team of scientists from the University of Utah published their own landmark study. The research, led by doctoral candidate Patrick Naple and S. Mackenzie Skiles, director of the Snow Hydrology Research to Operations Lab, solved a lingering mystery about the river's shrinking flow. The problem was dust. Red desert dust from the drying landscapes of the Southwest gets kicked up into the atmosphere and is carried hundreds of miles, where it settles on the pristine white snowpack of the Rockies. This dust dramatically changes the snow's albedo, its ability to reflect sunlight. Clean, white snow acts like a mirror, reflecting solar energy back into space and melting slowly, steadily, sending a reliable pulse of water into the headwaters of the Colorado River throughout the spring and early summer. But dust-covered snow is dark. It absorbs sunlight like asphalt. The University of Utah study proved that this darkening effect adds up to 10 millimeters of melt per day in high dust years. The snowpack essentially cooks from the top down. It sublimates, turning directly from a solid into vapor, bypassing the liquid stage entirely. The water is lost to the atmosphere before it can ever reach the river. The result is that the entire snowpack can disappear weeks earlier than it should, cutting short the melt season and starving the river system at its source. A drying landscape is creating the very dust that accelerates the drying of the landscape. It is a vicious feedback loop. This convergence of factors, a century of overallocation, a 2-decade megadrought, shocking groundwater depletion, and dust-accelerated snowmelt has brought the system to a precipice. In June of 2026, a white paper was co-authored by some of the most respected water scientists in the country, including Jack Schmidt from Utah State University and Ann Castle from the University of Colorado Law School. The paper's title was a stark warning. Update: Colorado River Basin storage continues slide toward system crash. Their analysis was not a prediction. It was a mathematical projection. If the basin experiences just one more dry year on par with 2025, the reasonably accessible storage in Lakes Powell and Mead will be mostly depleted. The dams would be forced into what is known as run-of-the-river operations. This is the system crash. It means the reservoirs would be functionally empty. The dams would no longer be able to store water and manage releases. They would act as simple conduits, passing along whatever meager flow the river provides in real time. There would be no buffer, no savings account. The water supply for 40 million people across 7 states and Mexico would be entirely dependent on the weather of the preceding week. The intricate system of dams, reservoirs, and canals built over a century to tame the river and green the desert would have failed. It would be the single greatest water infrastructure failure in American history. Now, here is the part nobody can predict. This physical crisis is colliding with a political one. The rules that govern how the river's water is shared are expiring. The 2007 interim guidelines, a set of emergency measures designed to manage the reservoirs in tandem, and the 2019 drought contingency plans, which added more layers of cuts, both expire at the end of this year. On December 31st, 2026, for the past 4 years, the 7 basin states, Colorado, New Mexico, Utah, and Wyoming in the upper basin, and Arizona, California, and Nevada in the lower basin, have been locked in contentious negotiations to write new rules. They have failed to reach a consensus. On January 9th, 2026, the Federal Bureau of Reclamation took the unprecedented step of publishing a draft environmental impact statement that laid out 5 different operational alternatives for the post-2026 era. It was a signal that the government's patience was wearing thin. Andrea Travnicek, the Assistant Secretary for Water and Science at the Department of the Interior, released a statement with the draft. The river and the 40 million people who depend on it cannot wait, she said. In the face of an ongoing severe drought, inaction is not an option. The federal government has given the states a final deadline, September 2026. If they cannot produce a unified agreement by then, the Trump administration has signaled it will impose its own solution. This would almost certainly trigger a legal war. The states, particularly those in the upper basin who feel the lower basin has used more than its fair share for a century, would likely sue the federal government. The case would escalate, inevitably landing before the United States Supreme Court. The fate of the river would be decided not by hydrologists and engineers, but by 9 justices weighing a century of competing legal claims. The entire foundation of water law in the American West would be thrown into question. The person at the center of this political storm is Aubrey J.D. Betancourt. In June 2026, she was announced as the administration's likely nominee to become the next commissioner of the Bureau of Reclamation. Currently the principal deputy commissioner, she is tasked with navigating this impossible situation. She must broker a deal between states with fundamentally opposing interests, under a ticking clock, with the threat of a system crash looming with every failed snowstorm. While the 2 great reservoirs, Powell and Mead, march toward their crisis points, a strange illusion of stability is maintained further downstream. Below Hoover Dam sits Lake Havasu, the reservoir created by Parker Dam on the border of California and Arizona. Tourists on Lake Havasu see a full lake. Its elevation is kept intentionally and artificially steady, held in a tight band between 440 and 450 feet. It is a decoy. Havasu is not managed for storage. It is managed as a forebay, a static passing tray. Its purpose is to maintain a constant water level so that two of the most important pieces of infrastructure in the country can function. On one side, the Central Arizona Project, a 336-mile canal, pulls water and sends it to Phoenix and Tucson. On the other, the Colorado River Aqueduct lifts water and carries it across the Mojave Desert to supply Southern California. Together, these two projects provide water for 27 million people. Lake Havasu is kept full so that the pumps can keep running, even as the reservoirs that feed it are draining away. And even in the face of what seems like an inevitable decline, human ingenuity provides some defense. The city of Las Vegas, which receives 90% of its water from Lake Mead, saw this crisis coming decades ago. If Lake Mead were to hit dead pool at 895 feet, the city would not immediately go dry. In 2015, after years of construction, the Southern Nevada Water Authority completed a $1.5 billion project known as the Third Straw. It is a 3-mile tunnel drilled under the lake bed, connecting to an intake structure at the very bottom of the reservoir. At an elevation of 860 feet, this intake sits well below Hoover Dam's lowest outlets. It can continue to pull water for the city even after the river has physically stopped flowing downstream to California and Arizona. It is an extraordinary feat of engineering. It is also a profound symbol of the region's new reality, spending billions of dollars to drink from the bottom of a dying lake. The groundwater depletion, the dust on snow, the political brinksmanship. These are the forces driving the river toward its endpoint. Each is an amplifier, a multiplier of risk, in a system that no longer has any margin for error. The lost groundwater is a debt. 27.8 million acre-feet of water, accumulated over geological time, has been spent in just over 2 decades. It will not be repaid in our lifetime, or our children's lifetimes. It is a one-time withdrawal from an account that is now fundamentally overdrawn. The dust on the snow is a thief, stealing the river's lifeblood before it is even born. And the political stalemate is a paralysis, preventing a rational response to a crisis that is accelerating month by month. The Bureau of Reclamation's January Draft Eyes is a document of last resorts, a set of painful choices no one wants to make. Cut agriculture? Cut cities? Allow the system to crash and let nature, in its newly brutal form, decide who gets water and who does not? For now, the system limps onward. Water managers make adjustments, releasing pulses from one reservoir to prop up another, fighting for fractions of a foot of elevation. They are managing the decline. But they are not stopping it. The trajectory is set. The combination of less water flowing in and more water being taken out, both from the surface and from the ground, is a simple, unforgiving equation. The balance is negative. The account is shrinking. The June 2026 white paper from Schmidt and Castle was not alarmist. It was arithmetic. What does a system crash truly look like? It means the hydropower that powers cities across the West goes dark. It means the municipal water intakes for cities that have not built a third straw run dry. It means the Central Arizona Project Canal, an artery of concrete that transformed a desert into a metropolis, becomes a ditch. It means the farms that grow the nation's winter vegetables go fallow. It means a legal and political crisis that would pit state against state, city against farm, neighbor against neighbor, in a fight for the most essential resource on Earth. It would be a cascade of failures, rippling out from the river to touch every corner of the American economy and society. The officials, scientists, and water managers involved know all of this. They work with these numbers every day. They watch the satellite data. They read the snow reports. They understand the physics of albedo and the politics of water rights. They are navigating a crisis that was set in motion 104 years ago, in 1922, by men who chose wishful thinking over scientific fact. The consequences of that choice are now arriving. The water they promised is gone. The stability they engineered is collapsing. And the future they imagined, a future of limitless growth in an arid land, is drying up before our eyes. So 3 questions now hang over the entire Colorado River Basin. How do you divide a river that is 20% smaller than your laws say it is? What happens when the hidden reserve of groundwater, the buffer that has masked the true severity of the crisis for 2 decades, finally runs out? And what does it mean for 40 million Americans when the system they depend on for everything enters a state of collapse from which it may never recover? The water that fell as snow in the Rockies last winter is right now flowing past Hoover Dam, on its way to the farms of the Imperial Valley and the faucets of Los Angeles. But the ancient water that sustained those farms is not being replaced. Deep underground, in the darkness of the aquifers beneath Arizona and California, the water table is still dropping. The pumps are still running. And the real deficit, the one you cannot see, is growing larger with every passing day.